So now that we've input each of our parts into this design file, it's now time to give these parts relationships and complete the assembly. So in traditional CAD softwares, we would use what's called constraints. So for example, in Autodesk Inventor or SolidWorks, we would use a series of constraints to align parts and fully constrain those parts together till we've got a complete assembly. But Fusion works quite differently and uses what's called joints. Joints in Fusion are quite a simple method of joining parts together, and it's actually very efficient to use. Joints are located under the assembly category here. We've got the option here for joint, or it's a shortcut J on the keyboard. So to begin with, I'm going to remove the data panel. So I'm going to click the X up there. We no longer need that. I'm going to press J on the keyboard. And as a demonstration, the first two parts that I join are this bracket arm here and our base plate. So this bracket arm is going to sit somewhere on top of there. I'm just going to throw that there for now. First at J on the keyboard, and got a toolbox pop up. And the process here is to select a joint on one part and then a corresponding joint on the other. For example, I'm going to move to the base of this bracket here. And as we hover the mouse over the face, we'll start to see all of these joining points appear. We can select one of these. So the one in the very center is the most logical one to go for in this case. So I'm going to select this joint here. And if I rotate the part, come onto the base plate, I hover my mouse over this part here, the corresponding joint would be right here in the center. So if I left click there once, we'll then see the bracket arm move to that position, and then we can offset it. So where those 2 points are joining, we can then offset it in this direction or this one. We can also rotate the angle as well. And you can control any of these parameters in these boxes here. And we press OK. And that's looking good. And if we look at the top of our toolbox, we've got position and motion. But if we go in the motion, we can then select different types of motion. So rigid is essentially rigid, nothing moves. We then got the option for Revolute. To about that joint between the two parts, this bracket arm can revolve. So it can revolve around, in this case, the Z-axis. Also, there's the option for slider and various other motions as well. But the majority of cases for using rigid motion, okay, we will be using Revolute for the pulley itself. We'll get onto that later. But let's make sure we got rigid selected. My position, I'm happy with that joint type. Happy with the alignments. Everything there is good. Press OK. And now if we try to move the bracket arm, so we're unable to do so. Holding down the left mouse button cannot move. The same with the base plate. Well, the base plate is grounded to the origin, and then the rigid joint between this bracket arm makes it unable to move. However, this bracket arm we can still move. So let's put a joint in there. Let's press J on the keyboard. I'm going to do this slightly differently. So instead of selecting this middle point here, I'm actually going to choose the center point of this circle and just show you that this is another method. And in fact, there are many different joining points we could use. But just for example, I'm going to select this joining point here. And then the corresponding point would be the center of this hole here. So left click once there. See those two parts come together. Happy with the alignment. We don't need to rotate that or do any offsets. And in terms of motion, we want that to be rigid as well, like so. That's good. It's okay. And now this part we cannot move as well. So good, we're getting there. And now we need to position our pin. Let's hit J on the keyboard. Again, a variety of ways in which we can do this. I'd say that the most simple way is to select the center point of this face here. So I've got my mouse over this face, and I'm going to move the mouse down. I can select the center point there, as we can see. So I'm going to left click once. The corresponding joint point will be over here. As I move my mouse over this whole feature, got the option to select this point here. So left click. Okay, that's good. Review's looking good. Everything there is fine. Click OK. Come out nicely. Again, that cannot move now. There's only one part left. Join, which is our pulley wheel. So we're going to do this slightly differently. I press J on the keyboard, and this time, instead of using the simple origin mode, we're going to use the between two faces. But let's select that. I'm going to come across to our pulley wheel, and we're going to select this face here. And then we need to select a second face. I'm going to choose the other face on the other side. And then what we're seeing is we have this kind of like plane in the center there. Now on that plane, there will be a series of points which we can snap onto. So as I move my mouse more towards the center, Again, we can see at the very center there is a snapping point. I want to take that snapping point and I'll left click once. And in terms of our component 2, we're going to do exactly the same. So between two faces, and this time I'm going to refer to the pin, although we could refer to the bracket arms. But for the pin, I'm going to choose this face, and then I'm going to choose this face. And then under my selection point, as we bring the mouse to the middle, we'll see this put a plane up here where we can select only one point here. A left click there once. Our pulley wheel move into place. By the preview, that is looking good. Happy with that. But in terms of the motion, I don't want this to be a rigid motion. I would like to show the animation and have the ability for this pulley wheel to rotate about that pin. So under the type, I'm going to go ahead for Revolute. And so about where that joint face is, we aren't rotating. So in this case, around the Z-axis. Now we could change that and rotate around the X, but that's not exactly what we're after. Or likewise for the Y. But yeah, the obvious one to go for is the Z. We look at that, that's what we're looking for. Now we do have motion limits, so we can set a minimum and a maximum. For example, I'm going to turn these guys on. We're going to put 180, and then we'll see we've got a 180 degree motion limit there. If we click to preview, we'll see it will only travel 180 and then back like so. I cannot do the full 360. That's not what we're after, but in certain circumstances, you may want that. We'll turn that off. I don't want there to be any limits. I want the full 360. Let's play that. Just make sure we're doing 360. Okay, looking good. Let's click OK. There we have our completed assembly and all fully jointed. And you will notice that about the positions of the joints are these indicators that there are joints there now. And we can right click on these. We can edit that joint. We can suppress the joint, animate that joint, and so forth. So we did want to edit that. Let's say that we wanted to change this one to a rigid joint, come into edit joint, under motion, we can change like so, but cancel there. And we can also see that if we come down to our timeline, we've then got the 4 joints there. So we should have 3 rigid joints and then the last Revolute joint, which is this one here. And again, we can edit any from here. So right click and edit joint. If we don't want to be seeing these indicators that we have joints present, we can come under the display settings and the object visibility, and we can turn off joints. And then you'll see that the indicators are gone, and then we can just refer to them from the timeline, or we can turn them back on like so. And so that is an overview of using joints in Fusion. I think it's a fantastic tool and an interesting and simplistic approach to forming constrained assemblies. I also think that compared to traditional CAD software, this is much more of an efficient process, but it can be slightly problematic when we're working with large-scale complex assemblies. Now, I would recommend having a good study of the joint tool and adjusting where needed any of the parameters, such as the alignments in the various motion types. If you have any questions regarding joints and assemblies, please do send me a message, and I'll see you in the next lecture.